Hello, my dear students. Welcome to my dear GW soldiers. Once again, very warm welcome in PW family, my dear. First of all, kindly let me know audio video is clear. Audio video is clear, my dear student. Kindly let me know. Each and every one, kindly let me know audio video is clear. Acknowledge, acknowledge, acknowledge everyone. Yes, Abhay. Very good evening. Very good evening. Very good evening. Yes. So, my dear GW soldiers, yes, Mohit Singh, very good evening. Very good evening. Ashutosh, very good evening. Gaurav, very good evening. Very good evening. Very good evening, my dear GW soldiers. So, today we are going to discuss, yes, Ritik Anand, very good evening. Today we are going to discuss revision through questions of the subject COA, Computer Organization and Architecture. Yes, Ritik Anand, very good evening. Abhay, okay. And today also it will be very interesting. Don't worry, Abhay Kumar. Today I will discuss each and everything also. And whatever I not taken in that revision part, like floating point and disk also, I will take today. The last I have with detail. Okay. So first of all, please tell me, let's start. So very good evening, my dear GW soldiers. Once again, very good evening. Today we are going to start revision through questions of the subject COA. And in this continuation, question number 1 is this one. What is the question number 1? The memory location 100 to 110 have a data value 1 to 11 in the sequence respectively. The initial value of R1 and R2 are 0 and 1000 respectively. These are the instructions. Now you tell me, these are the instructions I1 and I2. Now you tell me what is the value of R2 after executing the above sequence of the program 9 times, my dear. How much times? 9 times. Tell me fast. Yes, Priya Chaudhary, very good evening. Very good evening. Tell me fast what is the value. Each and everyone tell me fast. What is mentioned? Please try to understand. It is mentioned the value of 1000 to 1010. 1000 to 1010. Hundred to 110. Yes. 100 to 110 have a value of 1 to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And the register R1 having 0 and R2 having the value of 1000. And these are the instructions. I1 is what? I1 is what? Add R1. It's a immediate addressing mode. #1. And I2 is what, my dear student? Add R2 100 R1. 100 R1. Now you tell me what is the right answer. No, wrong, beta. Tanuj, wrong. Tanuj, wrong. Wrong, bacha. Yes, Gokhlesh, very good evening. Wrong, bache, wrong. Your answer is wrong. Yes, similar type you will get, but that answer is wrong, my dear. What is the concept for this? And believe me, today I will discuss floating point representation also, as well as disk completely. Don't worry about that. Here I am saying this will execute not 9, 10 times. You have to execute 10 times, my dear. 10 times. Please solve this one. Yes, Prashant, good evening, good evening, good evening, everyone. You have to solve 10 times. 10 times. You have to execute this value 10 times. And what is the answer? What is the value of R2, my dear? Tell me fast, my dear. Tell me fast. What is the value of R2 if you execute this code 10 times? If you execute this code 10 times. Tell me fast. Wrong, wrong. Abhay Kumar, wrong. 10 times it is executing. May I start? Yeah, you are solving. Tell me fast. Not getting the correct answer right now. Anuj, not correct. Please solve this one. Each and every one kindly solve. Wrong. Gaurav, wrong. Wrong. Everyone acknowledge fast. My dear GW soldiers, acknowledge fast. What is the correct answer for this one? You have to execute this loop 10 times, my dear. Then what is the value of R2? Yes, Tanuj. Now, listen, how we will do? Because it is mentioned, this is a immediate addressing mode. In R1, in R1 plus 1. You have to add in R1 plus 1, my dear. And second one is what? In R2, R2 plus M of 100 plus R1. Okay. Now, please look at the board. Yes, Shivam, very good. Very good, my dear. Very good. God bless you, everyone. Now, please look at the board. First, I will execute I1. What happened? R1 become 0 plus 1. R1 become 1. After that, I will do add. In R2, what I am doing? R2 plus memory location 100 plus R1. What is the meaning? In R2, what I am doing? What is the value of R2? 1000. 1000 plus memory location 100 plus R1. What is the value of R1? 1. So memory location 101, you will get 2. So 1000 plus 2. So what is the value for R2? You are getting 1002 for a first iteration. And for a second iteration, what happened? In a second iteration, what happened, my dear? Second iteration, what happened? Yes, Ritik Anand, very good, very good, very good, everyone. Second iteration, R1 plus 1. Now R1 become 1 plus 1, R1 become 2, my dear. R1 become 2. Now add in R2, R2 plus M of 100 plus R1. Mean to say R2 is 1002. 102 having the value 3, then you will get in R2 1005. Clear? Similar in each and every round. In each and every round, how you will get the answer, my dear? 1002 for first iteration, then 3 will be added, then 4 will be added, then 5 will be added, then 6 will be added, 7 will be added, 8 will be added, 9 will be added, and 10 will be added. This is the first iteration. This is second. This is third iteration, fourth, fifth, sixth, 7, 8, 9. Clear, bacha? And 10th iteration, 11. So what is the correct answer? 1065 is the correct answer, my dear. 1065 is the correct answer. Crystal clear, everyone? Yes or no? Each and everyone kindly let me know. Crystal clear? Acknowledge fast, my dear student. Crystal clear? Kindly make a heart. if you got it. And you will get the very beautiful concept of the floating point also. Don't worry, I will take. And please, now this is the next question. Consider a system with a instruction which use 19-bit instruction set, 8-bit address is 8-bit. There are 6 2 address instruction and x 1 address instruction. Then what is the maximum value of x if 0 address instruction is 65,536? Solve, Tanuj. Beta, solve everyone. Solve everyone. What is the correct answer for this one? And please do one thing. Anna, you are doing one mistake. You don't memorize the questions. Every time you just take the value and take as a challenge and solve it. That's all. That is your attitude. Because in the OS, in the COA also, some of the PYQs little bit change. If you memorize the questions, definitely you will do the wrong, Tanuj. Getting my point? Tell me fast, my dear. Tell me fast. What is the correct answer for this one? It is a question from expand opcode technique, my dear. Expand opcode technique. What is asking, my dear? Here instruction size is given 19 bits. Okay. 8 bit ka address and there are 6 2 address instruction. Wrong, beta, wrong. Gaurav, wrong. Each and every one. Solid. Yes, Prashant Jaiswal, very good evening. Very good evening. God bless you. Tell me fast, what is the correct answer for this one? Tell me fast, my dear. What is the correct answer for this one? And everyone, solve everyone, solve. What is the correct answer, my dear? Here it is mentioned instruction size is 19 bits. Now, address size is 8 bit. Address size is 8 bit, my dear. And there are 6 2 address instruction. How much 2 address field? 6. And 0 address field 65,536 and asking about the 1 address instruction. Tell me fast. Tell me fast, my dear. Wrong. Gaurav, wrong, beta. Answer is wrong. Each and everyone kindly solve, please. Abhay Kumar, wrong. Everyone, tell me fast. What is the correct answer? Wrong. Wrong, Shivam. May I start? Let's check it, my dear student. Instruction size is fixed at 19 bits and the length of address field is 8 bit. There are 6 two address instruction and X one address instruction. Now we will check, my dear. Opcode, address field 1 and address field 2, my dear. What is the instruction size? 19 bits. How much? 19 bits. And address is 8 bit. 8 bit. So what is the length of instruction of code? 3 bit. Total number of operation is how much? Total number of operations in two address field is how much? 2 raised to power 3. 8 operations are there, my dear student. There are 8 operations. There are 8 operations. Shivam Jangid, wrong beta. Wrong. There are 8 operations and given is how much? 6. Then what is the number of free opcode? Number of free opcode after allocating two address instruction, 8 minus 6, 2 will be free. Now we have to see for one address field. One address field. So opcode and only one address field of 8 bit. So if it is 8 bit, then the opcode will be 11 bit. Total is 19 bit na. Now total number of operations is how much? In one address instruction, you can say free opcode. What is the free opcode? Free opcode is how much? 2. And how many opcode bit increment? 8 bit. So 2 की power 11 minus 3. You can say 2 into 2 की power 8. How much you are getting? 2 raised to power 9, my dear. 2 raised to power 9. Very good, Gaurav. Now you are getting correct. 2 raised to power 9, my dear. 2 raised to power 9. And I don't know how many X. I am assuming X. One address instruction is how much? X. Then number of free is how much? Number of free is 2 raised to power 9 minus X, my dear. Now I will calculate for 0 address. I will calculate for 0 address instruction. So what is the opcode length? What is the opcode length for a 0 address instruction? Opcode will be 19 bit, my dear. 19 bits. Then total number of operations is how much? 2 raised to power 9 minus X multiplied by 2 raised to power earlier 11. 19 minus 11. So how much we are getting? 2 raised to power 9 minus X multiplied by 2 raised to power 8. That is equivalent to 65,536. Clear, everyone? 65,536. So you can write this one is 2 raised to power 16. 2 raised to power 9 minus X multiplied by 2 raised to power 8. This will be cancel out. Then how much we are getting? We are getting 2 raised to power 8 equal to 2 raised to power 9 minus X. So X value will be 2 raised to power 9 minus 2 raised to power 9 minus 2 raised to power 8. You will get 256. 512 minus 256, my dear. So 256 is the right answer. It is crystal clear. Kindly write down in chat box, my dear. Kindly write down in chat box. Now solve this one. After that, solve this one, my dear. Crystal clear this one? Crystal clear? Shivam now getting correct. Gaurav, Prashant Jaiswal, each and everyone. Now solve this one. Solve this one, bacha. Yes. Please, again I am saying, don't do the silly mistake. You have 65 questions in the examination, but don't do the silly mistake. You are not giving any bank PU examination. In a 1 hour you have to solve 100 questions. Then speed is very high required. Very high speed is required. No, my dear. Don't do the silly mistake this time and be relaxed, my dear. Be relaxed. And why I am coming with the similar type of questions which you seen already? Because I want to boost your confidence also. Tanuj, are you getting my point? Tanuj, I want to boost your confidence also. So treat as a new question and solve everyone. Okay, bacha? And I will revise the floating point and disk structure also. So don't worry. Tanuj, are you getting? Each and everyone kindly acknowledge. Acknowledge everyone, acknowledge everyone, acknowledge. Yes. What is the question? The initial value of R1 and R2 are 2000 and 4000 respectively. Okay. You can write R1 is how much? 2000. R2 is how much? 4000. And what is mentioned? Memory location 2000 having the value 10 and memory location 4000 having the value 20. Having the value 20. Okay, Tanuj. Okay, beta. Having the value 20. Now, this is the I1. What is the I1? What is the I1, my dear? Add in R2, R2 plus memory location 1000 plus R1. Similar type of question asked in GATE also, and you will find in test series also. Similar type of questions. So what is the value of R2? R2 value is 4000. M of 2000 plus R1 is also 2000, my dear. Then what you get? Memory location 4000 content will be added with 4000. So what is the memory location 4020? So what you are getting? You will get 4000 plus 20. So you will get 4020, my dear. 4020. Now next I2 in a R2 plus M of R1, because it is a register indirect, beta. It is a register indirect. R2 will be 4020. M of R1. R1 means what? 2000. What is the value of 2000? 10. 4020 plus 10, 4030, my dear. So R2 will be 4030, my dear. 4030 is the right answer, my dear. Crystal clear? Beta, why you are giving the wrong answer, some of the students? Now, this is the 4030. Now, this is a one question next. It has having 31 control signals. 31 control signals. And all instruction take 11 cycle. Total 160 instructions are there. And it is using vertical microprogramming. Then what you explain? First of all, this is the second question. The first question, size of control word. Size of control word in byte. Tell me fast. Size of control word. Then we will discuss the size of control memory, my dear. Tell me, tell me, tell me. Tell me, my dear. What is the correct answer? And then first of all, I will teach the floating point wala concept also. Hai. And I will teach the disk structure also. Don't worry about that. Please, my dear, kindly participate in each and every question. You assume in this type of question you will find in the GATE 2023. So how you deal with this? Your attitude will be like, I am giving the paper, so what is the correct answer? Forget each and everything. Just solve it and tell me the correct answer, my dear. Okay. Tell me fast, what is the correct answer? Thirteen-bit is the wrong. 13-bit is the wrong. 13-bit is the wrong, my dear. If I'm wrong, tell me, everyone, everyone, everyone. If I'm wrong, 24 is the wrong. Acknowledge fast, my dear. Acknowledge fast. Do it with correctly. Tuesday wrong. 11 is not the right answer. Why you are doing the mistakes? 11 is not the right answer. Till now not getting the correct result. Kindly acknowledge fast what is the correct answer. What is the correct answer? Each and everyone tell me. Not getting the correct till now. I am explaining what is the number of instructions. Such type of question already asked in GATE 2 marks. Number of instructions is how much? 160. And each instruction take till now not getting the correct answer. Each instruction takes 11 cycles. Then total number of micro operations, you can say micro instructions, is how much? 160 into 11. Please remember the concept of control unit. 1716 micro instruction or control word. Yes, now Sujay, correct. So what is the control memory, my dear? Your control memory will be 1760 control word. So what is the car? You can say address field. You can say NIA. That will be how many bits? 11 bits. Your address will be 11 bits. Because we using vertical microprogramming, my dear. Vertical microprogramming. Then how many signals are there? How many signals? 31 control signal. So for a 31 control signal, log base 2 of 31, how many bits are required? 5 bits. So what is the instruction size? Control field and car. This is what? One control word. So this one is 5 bit and car is 11 bit. So you will get 2 byte. You will get 16 bit or 2 byte, my dear. Tanuj, are you getting? Each and everyone, are you getting? So Rishikesh, the answer will be 2 byte. How the control memory is 760? Because you know what is the control memory in a microprogram control unit? It stored the micro instructions. So here micro instruction is not given. Here neither control word is not given. Here instruction is given. Here total is 160 instructions and each instruction take 11 cycle. Please recall that concept T1, T2, T3, T4. Each instruction take T1 to T11, 11 micro operations. So total number of micro operations for 160 instruction is how much? 1760 micro instruction या micro operation या control word. So this is the size of control memory. That control memory having 1000 1760 control words, and each control word how much size? 2 byte. 2 byte, my dear. 2 byte. 2 byte. Then what is the size of control memory, my dear? Control memory is 760 control words. 760 multiplied by 2 byte. 35 20 byte. 35 20 byte. Crystal clear, everyone? Each and everyone crystal clear? Kindly let me know. If yes, then write down heart in a chat box. The chat must be flooded from your chat. Chat box must be flooded, my dear. Acknowledge fast, fast, fast. Now solve this one. Shivam Jangid, crystal clear? Crystal clear, beta? Now solve this one. Yeah, do one thing. First of all, I am explaining floating point representation. Now you tell me, first you want to solve the questions. Yeah, I am explaining floating point, which I miss because it is a very important and ask in 2 marks in current scenario. Tell me fast. Your chat must be flooded, beta. Acknowledge fast. What you want? Because I promise na I will explain floating point and will take some questions. Yes. I will do both. First we'll solve the questions. Rishikesh, solve this one. What is the correct answer? What is asking, my dear student, what is asking? CPU has 32-bit physical address, 512 KB memory, write through cache. Earlier it was write back. Now I am taking the question of write through. The cache is 4-way set associative with block size 16 byte. Then what is the tag memory size? Mean to say, here I am asking each and everything, my dear. Tell me fast. What is the correct answer? Everyone acknowledge. Tell me fast. Each and everyone, tell me fast. What is the correct answer? Here, first of all, I told na you have to develop that type of attitude. It is a set associative memory. So what we have to write? Tag, set offset and word offset. Main memory physical address is how much? 32-bit. Block size 16 byte. Mean to say 2 raised to power 4 byte. Then the word offset will be 4-bit. And cache memory size is how much? 512 KB. 512 KB. Maybe your answer is right, maybe your answer will be wrong. Please check it, Gaurav. Check it once again, beta. Check it once again. Okay. Yes, Naj, I will explain floating point also. I will do both in today class. This one and questions and floating point also. Don't worry, beta. First I am taking question, then I will take floating point also. I will not leave the class before the floating point explanation. It's my promise. Okay, bacha? Don't fear. Your Vijay sir is here. So number of lines, how you calculate? Cache memory size divided by block size. So 2 raised to power, you can say 19. Divided by 2 raised to power 4, you will get 2 raised to power 15. And what is the number of set? It is a 4-way na. 2 raised to power 15 divided by 2 raised to power 2, 2 raised to power 13. So you will get 13. So what is the tag? Tag will be 15 because 32 minus 13 plus 4. You will get tag 15 bits. You will get tag 15 bits. Now what is the tag memory size? What is the tag memory size, my dear? You can directly write number of lines into tag bits. How many number of lines? 2 raised to power 15. Tag bit is how much? 15 bits. Yes or no? Yes or no, my dear? So how much you are getting? 2 raised to power 5 multiplied by 15 multiplied by 2 ki power 10 divided by 2 raised to power 3 in bytes. So you will get 60 KB. 60 kilobyte, my dear. C is the right answer for this question. Very good, everyone. Bacho, if you are getting, kindly make a heart, everyone. This is also very good question of pipelining of control dependency. Naj, I will explain floating point definitely with not only floating point, with IEEE 754, single precision, double precision, each and every concept of this one. Okay, so don't fear. First of all, you solve this type of questions. Yes, intentionally I told Gaurav, you have to be confident your answer. Okay, that is also required. Naj, don't worry, beta. I am saying na, I will take because it is also not so much questions. I will take floating point in detail. Don't worry. Then I am assured na ki I have to explain floating point because otherwise that thing ki question is remaining. That thing penetrate in my mind also. Ki yes, we have to solve the questions. First to solve the question, then I will explain floating point with questions also. Okay, it's my promise. I am telling. Yes, definitely I will explain. And explain with detail also, in detail. Yes, everyone, please read this question. Bacho, this type of questions you will get in gate 2023 also, because each and every year this type of questions you are getting. So please try to solve this type of questions. Okay, what is mentioned? Consider a hypothetical processor with 10 pipelining stage, perfectly balanced, and following are the branch frequencies. Jump and call 13%, conditional branch 20%. Out of that, taken conditional branch is 40%. Okay, bacha. Unconditional and conditional branch are resolved at the end of fifth and sixth stage respectively. Processor always execute the branch successor regardless of target and flush the pipeline if branch is taken. This is the concept. So it is asking speed up factor. It is asking speed up factor. Each and every my dear GW soldiers, kindly solve this one. Kindly solve this one. Why you lethargic today? Why you lethargic today? You are not acknowledging in chat box. Why you lethargic? Where is the Josh? I know this time we are cold everywhere. Even at my place also last 2 days there is a heavy rain. But Josh must be always high and show must go on, my dear. Yes, everyone. Yes. Solve, please. Solve, please, everyone. What is the correct answer? Each and everyone tell me fast. What is the correct answer? Tell me, my dear. Here it is mentioned unconditional, you will get fifth stage. So what is the branch penalty for a unconditional? Branch penalty for unconditional instruction, unconditional branch, fifth stage means 4. And for a conditional you will get sixth stage means 5. Okay. And what are the frequencies are given? These are the frequencies are given. Now you can calculate what is number of stalls per instruction. Number of stalls per instruction, my dear. How you calculate? This 13% will take 4 stalls plus it is mentioned 20% are conditional and out of that 40% satisfy the condition. 40% satisfy the condition means 20% are conditional, 40% satisfy the condition, my dear. So what you can say 0.52 plus 40, 0.92. What is the average instruction execution timing? 1 plus 0.92 cycle. How much you are getting? 1.92 cycle. Here because very good Shivam Jangid, very good. Here because perfectly balanced it is mentioned. So speed up factor is what, my dear? Speed up factor is what? Pipeline depth, number of stage divided by 1 plus number of stalls per instruction. Clear? So what we can say? 10 divided by 1.92 because cycle time and cycle time will be cancelled out, then how much you are getting? 5.2 something. So 5.2 is the right answer, my dear. 5.20 is the right answer. Maybe 2021 is the right answer. Clear, everyone? If it is crystal clear, kindly write down in chat box, everyone. Clear? Tell me fast, my dear. Because it is mentioned कि these are the unconditional jump. I told na, jump and call are the unconditional. These are the conditional. Out of these, only 40% time taken the conditional. 40% time taken the conditional, my dear. Now solve this question. Solve this question, my dear, of IO. Now, definitely, I will explain floating point. Only 2-3 questions you have to solve. After that, we will discuss floating point representation in complete depth, my dear. In complete depth. Okay. Gaurav, wrong beta. Wrong. Each and everyone. It is mentioned a device with data transfer rate of 50 kbps. How much? 50 kilobyte per second is connected to the CPU. Data is transferred byte-wise. Let the interrupt overhead is 3000 nanosecond. Then the byte transfer time between the device interface register and CPU memory is negligible. Now it is asking the performance gain of operating the device under interrupt mode over program control mode. Tell me fast. Gaurav, your answer is wrong, beta. Tell me fast. Each and everyone tell me fast. What is the right answer? Everyone acknowledge fast. Why you are not replying? Listen. Here, what is mentioned? 50 kbps. What, bacha? 50 kbps. What is the meaning? 50 kb in 1 second. So in a 1 byte, how much time it will taken? 1 upon 50 k second. How we can write? 1 upon 5 into 10 ki power 4. Yeah, can we write 1 upon 5 into 10 raised to power minus 4? So what I did, I multiplied by 100 and divide by 100. So what we are getting, beta? We are getting 20 microsecond. We are getting 20 microsecond in programmed IO. In programmed IO, my dear. In program IO, in execution time in program IO, we are getting 20 microsecond. How we are getting 20 microsecond, my dear? You will cancel this one 20 into 10 ki power minus 6 second. So minus 6 become micro. And in interrupt driven it is mentioned 3000. Interrupt driven it is mentioned 3000 nanosecond. So how can you write 3000 multiplied by 10 ki power minus 9? So 3000 10 ki power minus 9. Then what will happen? What will happen, my dear? What will happen? What will happen? This will be cancelled. Then how much you are getting? 3 into 10 ki power minus 6. Mean to say 3 microsecond. It is asking performance gain. Performance gain. So what you can say? Execution time in programmed IO divided by execution time in interrupt IO. How much? 20 by 3, 6.66, my dear. Each and every one, because sir, it is asking first interrupt. You know performance is inversely proportional to the execution time, my dear. Still clear, everyone? Still clear, Gaurav? Now you are doing the correct. Solve this one. Solve this one, everyone. Solve this one. Then I will explain other concept of floating point representation. Do it fast. Similar type of question asked in 2 marks GATE examination. Each and everyone solve, please. Solve, please. That is mentioned, na Shivam? That is mentioned. Interrupt overhead means interrupt will be used. So in a interrupt driven IO, what is that data transfer time? Interrupt time is also considered, na? That we consider interrupt time. Or remaining time is mentioned, na Shivam Jangir, negligible. Getting, Shivam? Now, listen, it's a very easy question. Count value is how much? 16 bit. Count value is how much? 16 bit. Then how many total number of byte can be transferred one at a time? Total number of byte can be transferred 2 raised to power 16 byte. 65,535 byte. 65,530. Getting my point? 65,535 byte. And how many byte we have to transfer? Total number of byte we have to transfer. Sixty-two 247 kilobyte. 247 kilobyte. Now it is asking ki how much time DMA controller will get. So it's very simple. What? 32,247 kilobyte na, 1024 divided by 65,535. When you divide, definitely you will get 504. It's a very simple question. Similar type of question, yes, similar type of question asked in GATE also 2 marks. Now, because acknowledge first of all till now. Now I am going to start my favorite topic, floating point representation. Each and every topic are favorite. First of all, clear है बच्चा? Till now everything is crystal clear. Till now everything is crystal clear. May I start? Naj. Each and every one, kindly write down in chat box. Akshay, very good beta. Each and every one, kindly write down in chat box. So we will start. You know, my dear, last 2 days I am also not feeling well. And I am not in the condition because there is a severe cold. I will tell you the concept as well as I will take the questions. Okay, Gaurav, I will explain floating point complete. I will explain floating point completely with the lots of questions. Don't fear. Okay, bacha. Now, listen what I am telling. First of all, why floating point is used? Why floating point representation is used? Because you know the fixed point representation. You sorry, you can't represent zero. Yeah, you can't represent a very small number and you can't represent a very large number. So it is possible with the help of, then that is 5 point something, 5.2 आएगा बेटा राजा गौरव, 5.2. Now check it. You are doing maybe some calculation mistake. Check it once again. And now what I am saying, in a floating point representation, please try to understand simple things in a simple manner. How we represent we represent in the form of S, E and M, my dear. How we represent S, E and M. Please try to understand. S, E and M, my dear. S is what? Sign bit. If it is positive, then 0, or negative, then 1, my dear. Clear? Now, E is what? Bias exponent. E is what? Bias exponent. Sometime you will get E, sometime you will get BE. Sometime you will get BE. Unconditional, Gaurav, we taken unconditional already. We taken, this is only unconditional, 13%. 13% are unconditional, 20% are conditional, and remaining are the normal instructions. Normal means normal instructions. Clear? Gaurav. Now, here BE is what? Capital E is what? Small e plus bias. Please put your pen down. Small e plus bias. Sir, yeah, you will get sometime bias exponent equal to actual exponent plus bias. Actual exponent plus bias. Or M is what, my dear? M is what? Mantissa. M is what? Mantissa. Naz, are you there? Are you there, beta? Naj. So what I am saying, my dear student, like S, E and M. How we write? S is what? Sign bit. That always 1 bit. That always 1 bit. And if it is not a single precision and double precision, then they will give the value of E and M. They will give the value of E and M. Here E is what? Exponent. And M is what? Mantissa. And how you represent? Either plus. Okay, bacha. Okay, Gaurav. Either plus or minus, and x dot something multiplied by 2 raised to power e. 2 raised to power e. Clear, bacha? What I am saying, multiplied by 2 raised to power e. This is the small e. What is the capital E? देखो बच्चों, how it will be represent. अरे don't fear, your Vijay sir is here, my dears. Listen carefully, please. First of all, acknowledge you are not giving the energy to me also. Tell me fast. Write down in chat box. Now, what I am saying, my dear, how you write point something, that is what Mantissa, multiplied by 2 raised to power small e. Multiplied by 2 raised to power small e, my dear, 2 raised to power small e, my dear, 2 raised to power small e. Now, how we calculate this? Is small e is what? Actual exponent. Actual exponent. देखो, you can use base decimal also, but in a computer number system we generally use 0 1 binary. That's why here I am taking 2 raised to power e. You can take 10 also, but in the examination 10 is not asking because binary is asking. We computer understand binary 0 1, so that's why base is 2, my dear. Clear bacha? Now listen what I am saying here. First of all, you can calculate bias exponent. How you calculate bias exponent? Actual exponent plus bias. Naj, actual exponent plus bias, or I am telling capital E equal to small e plus bias. Sir, what is the value of bias? Bias is nothing 2 raised to power exponent में bits minus 1. Exponent bits minus 1. For example, if your exponent is k bit, if your exponent is k bit, then bias will be what? 2 raised to power k minus 1, my dear. K minus 1, my dear, k minus 1. Crystal clear, everyone? 2 raised to power k minus 1, my dear. Bias will be 2 raised to power k minus 1. Now, sir, why we use the biasing? Because if my exponent is negative, for example, I am getting, let's suppose, 2 raised to power minus 5. Then how you can represent? Because sign bit is used to represent the number. Either it will be positive or it will be negative. It will be positive if it is 0, or if it is negative then it is 1. But if power is negative, how can you represent? You would have to take 2's complement, but you are in the dilemma stage. You are in the confusion state कि this is a 2's complement value or this is a normal value of small e or capital E. So what we adopt? We do the what we done? We normalize the exponent. And what is the process? Biasing is the process. Ki what is the meaning of biasing? Biasing is a process to convert a negative number into positive and positive also positive. So no need to take any tension about the negative exponent. And why only this one? You know the property of number system also. Ki if you add, let's suppose I'm telling with example, don't worry. Now, for example, if your number is exponent is 4 bit, then what is the bias? 2 raised to power 3, 8 is the bias. And if your number is 4 bit, then what is the maximum sign bit? If we using sign representation, then minus 2 raised to power n minus 1 to plus 2 raised to power n minus 1. Clear bacha? So minus 8 to plus 7. That's why to make it neutral, what is the maximum value be required? Plus 8 will be required. Crystal clear, everyone? So this is the way ki we are using. No need to focus on this one. You know 1's complement, 2's complement, each and everything. Don't worry about that. Now, here it is mentioned 6.5. I am explaining. I will take after 2-3 questions which you have to solve. 6.5. How you write 6? 4. Acha, first of all I am telling how you write each and every one. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. 2 raised to power minus 1, 2 raised to power minus 2, 2 raised to power minus 3, 2 raised to power minus 4. 1 by 2, 1 by 4, 1 by 8, 1 by 16, 0.124816, blah blah blah. Clear, everyone? Now, if I have to write 6.5, then for a 6.5, what we have to do? This bit 4 plus 2 will be set, and 0.5 is what? This one is 0.5, this one is 0.25, this one is 0.125. Clear? So for a 0.5 this one will be set. What you are getting? 110.1. Crystal clear everyone? 110.1. 110.1. Now what I am doing? I am converting point. I am shifting right shift. So my dear, what happen? What happen when I am doing right shift? Then exponent will be positive. How much you are shifting? Earlier your bit is point is here na. Now you shift here 1, 2, 3 digit. How many shift you are digiting? Shifting 3 digit. How many shift? 3 digit. Which one? Right. Now listen, most of the student done the wrong. They have a confusion. Ki sir, whenever we doing the right shift, Mantissa alignment in right shift, then power will be positive or negative. How you remember? Ki if you are doing right any noble work, देखो just relate with yourself. If you are doing right shifting means you will be positive, you will get the some benefit, you will get the advantage, you get the mental peace, you get the morality. Getting my point? So how this is the funny, but you can remember कि whenever we do the right shift means point will be this place. What you are doing? You are shifting these data into right hand side, है ना? Then what happen? Power will be positive. So here S will be 0 because it is a number positive, and this is part is called Mantissa 1101. And what is the small e? Small e is 3. Clear? I am giving the proof also. Naz, beta, I am giving the proof also कि when you write, then how the power will be positive. Sir, can we get this value from this one to this one? Yes. You can understand 0.1101 multiplied by 2 की power plus 3. You know what is this? 2 की power minus 1. You know what is this? 2 की power minus 2. You know what is this? 2 की power minus 4. Because minus 1, minus 2, minus 4, minus 3. Yes या no? Multiplied by 2 की power 3. So how much we are getting? 2 raised to power 2 plus 2 की power 1 plus 2 की power minus 1. So you are getting 4 plus 2 plus 0.5. Crystal clear everyone? If it is crystal clear, kindly write down in chat box. So what we can conclude? What we can conclude, my dear, कि Mantissa alignment is the process to adjust the decimal point. In this right alignment, increment the exponent, and left alignment and left alignment decrement the exponent. Clear? When you shift the right, then you will get the plus. When you shift the left, you will get the minus. Like I am telling here, कि when you shift right, my dear, when you shift right, you will get positive exponent. You will get positive exponent. When you shift left, like this one is na, so you are shifting left. How many bits you are shifting? Earlier it was plus 5. 1, 2, 3, 4, 5, 6, 7, 8. You writing 1.01. Then minus 8. Crystal clear? Now there is any confusion in your future कि what is the right shifting, what is the left shifting, how it will be positive, how it will be negative. If you get any confusion, keep this example in your mind. Then definitely you will get. You thinking कि right now it is easy, but beta whenever it is given in the 32-bit format na, it will be complicated, and कि we can write plus or minus. If you take plus, your answer will be different. If you take minus, your answer will be more different. Clear everyone? Now, first of all, acknowledge fast. Till now, crystal clear. Acknowledge fast, my dear. Acknowledge fast. Each and every one. Why you lethargic today? Prashant, Shivam, Ritik, Indian, Rishikesh, Anuj, Okhlesh. Now, what I am saying, my dear, there are two type of Mantissa representation. Normalized Mantissa, there are two type. Explicit means what? 0.1. and implicit means what? 1 point something something. 1 point something something. Okay, देखो, either you can read, either you can write. Okay, either you can store, yeah, you can get the value formula also. How we write explicit 0 point something, and how you write implicit 1 point something. So what is the value formula? Value formula means what? How to get your number if this is represented in this form? Minus 1 की power s, because you represent 0 dot m multiplied by 2 की power. Or my dear, you know one thing, capital E is what? Small e plus bias. Small e plus bias. Then what is the value of small e? Capital E minus bias. Sir, how I will get capital E? This is given. This is given. And how I get the bias? 2 raised to power k minus 1. 2 raised to power k minus 1. And here minus 1 की power s, 1 dot m into 2 की power e. And how I will get this e? Again same thing, capital E minus bias. Sir, let's take a practical example. Yes. Listen first of all. Explicit means what? 0.1. Yani after the point, immediate bit should be 1. After the point, immediate bit should be 1. And implicit means what? Before the point, 1 means 1 point something. Like, please put your pen down, everyone. Here I am solving this question in explicit. Explicit means what? After point you will get 1. So what we required? 1 0 1 1 1 into how many bits I am shifting? 1 2 3. 2 raised to power plus 3. So what is the mantissa? In this case 1 0 1 1 1. What is the small e? 3. What is the sign bit? 0, because it is positive. What is the capital E? You can calculate. How? E plus bias. Crystal clear, everyone? Each and everyone crystal clear? Yeah, bacha, ऐसे याद in Akshay, no need to remember in this form. If it is given in any format, you want a value, that is called value formula. You are reading. When you storing, you can store. Don't remember in this form. Okay? Otherwise, you will be confused in the last day. How, what with they? Or in what form it is given, you can represent in another also. Like, if this form is given, you will get the value. If this form is given, you can represent in this form also. I will take both also. But don't remember, because try to understand on the third fab, your mind, this one remember, this one remember, this one remember. Not remember, yaar. Not remember, my dear. Try to make it simplex, because complex to iota. Clear, bacha? Complex to iota, my dear. Now, listen. Here it is mentioned 21.75. Please put your pen down. 21. How you write 21? 16, 8, 4, 2, 1. 0.75, 0.5 and 0.25. Now, you can see. Which one is asking? Akshay. Akshay, here you are getting two things. Now, no need to remember. I clear your doubt in this slide. I clear your doubt. If it is asking 21.75 is there, you have to represent in this format. Means you are storing. So how you write 21.75? You write on 16, 4 and 1. 0.5, 0.25. Clear? Implicit means what we have to do? We required point here. How many bit we shifting? 1, 2, 3, 4. So, small, this is the mantissa. Small e will be 4. Now here capital E will be, exponent is 7 bit. Then what is the bias? What is the bias? 2 raised to power 7 minus 1. Bias will be 64. Bias will be 64, my dear. Bias will be 64. Please try to understand why you make it complex. Yeah, try to simple as much as possible. Bias will be 64. Small e is how much? 4. So capital E is 68. Okay. So what you get? You get mantissa, you get capital E, you get sign value. Sign value. Now how you represent? 1 bit for sign, because it is a positive number, 0. And 7 bit for capital E. What is the capital E? That is called bias exponent. How we get? Small e plus actual exponent plus bias. So what is the value? 68. You have to write in 7 bits. 64, 32, 16, 8, 4, 0, 0. Clear, bacha? You are getting these things. And what is the mantissa? 0 1 0 triple 1 0 1 0 triple 1 and remaining all bits remaining zeros, and it doesn't affect your health. I told the reason. Now it is asking in hexadecimal. Either you can store in this value, yeah, you can store this value in hexadecimal. Then what you have to do, make a combination of 4 bits. Then what we are getting, 12 means C, 5 4 4 4 4 5 C, 4 4 5 C. And if this data, beta, padding will be added always this side. Let's suppose Menti size 18 bits. How many bits? 18. Just wait. I am giving the proof. Why you fear? Your Vijay sir is here. I am telling. Here it is 18 bit. Let us assume. I am adding here. Sir, it not effect? No. How? Please show. Yes. Because it is a implicit na. 1 dot s multiplied by 1 dot 1 की power s multiplied by 1 dot m into 2 की power e. So what is the capital E? Here 68. What is the bias? 64. What is the value of this? 68 na? 64 plus 4. Or what is the bias? 64. Then if I am writing 1.010.01011, please look at the board. 111 2 की power 4. Most of the student thinking of digital electronics concept कि LSB portion we have to add 0. Wrong, my dear. You have to MSB portion you have to add 0. No, wrong, my dear. It will be added on LSB side. Like I am showing na, it not affect the value. How? Please check it. How many shift you have to do? Plus 4 na. 1 2 3 4.11. Remaining will be 0 0 0 0. So what you say? 1 2 4 8 16 16 4 1 and 0.75. You are getting 21.75. Crystal clear? Prashant, Akshay, each and everyone, you are all doubt crystal clear? Acknowledge fast, my dear. Acknowledge fast. Now you solve this question. You solve this question. But my dear, what happened? It is mentioned plotting point 32 bit. First of all, acknowledge everyone. Acknowledge. So what happened in IEEE? देखिए बच्चा, please try to understand. In a normal case, bias will be 2 raised to power k minus 1. In the IEEE, what happened? Bias will be 2 raised to power k minus 1 and minus 1. Like here, bias will be how much? In a single 32 bit, 2 raised to power 8 minus 1 minus 1. 127. Bias will be 127. Now you tell me what is the value. You tell me what is the value, my dear. Each and everyone acknowledge fast. What is the value? You will get it. Tell me fast, tell me fast, tell me fast. Thank you, Jaiswal. Ritik Anand, very good. Tell me what is the right answer for this one. It is mentioned implicit. And implicit will give the more accuracy. You know, because data bit, if we have a Mantis a very less size, then implicit is best. But it is mentioned in the question, beta. Don't worry about that. It is normalized or not. Tell me beta fast. देखिए बच्चों, how you can write? What is the value of E? 1 2 4 8 16 32 64 128. So capital E will be 132. Bias will be 127. S is 0. What is the value formula? Minus 1 raised to power S 1 dot m multiplied by 2 की power small e. Yes या no? 2 raised to power small e. Yes, very good bacha. 2 raised to power small e. Yeah, can I write this one capital E minus bias directly? So minus 1 raised to power 0. 1 dot m is what? 1 1 0 0 0 0 0 0 0 0 0. 2 raised to power 132 minus 127. So how much we are getting? 1.110000000000 2 की power plus 5. What you have to shift? 5 bit. 1 2 3 4 5. 0.0000000. 1 2 4 8 16 32. कितना आया? 56. Crystal clear everyone? चमका? If yes, then write down in chat box. Naj. Here you can see you are getting 56. Now solve this one. Minus 14.25. Minus 14.25 and solve this one, my dear. Single precision format. What is the hex value? What is the hex value? Yes, Ashwin. And already in one batch, I am taking the DBMS in weekend English batch. Weekend English batch. And you will get more information. Just visit the website and you will get the notification also. Stay tuned. Stay connected. Ashwin Mahajan. Right now we are doing this revision for a GATE 2023 students. No beta, no. In a Akshay, in a floating point, what happened na? Floating point, single precision and double precision, bias will be what? 2 raised to power k minus 1 always. And floating point having the fixed format also. Yeah, Shivam. But first of all, each and everyone, those are watching what I am saying, ki please, 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 you have exam, give it. What happened? Or what is the worst case? You will not get the best rank. You will not get the best rank. We have both, Ashwin. We have a pure both batches. We have a English batches and pure English. In pure English, we will not speak any Hindi. And in English, we mix Hindi plus English. Okay. In general talk in Hindi, concept in English. Don't worry about that. But in English batch, each and everything in English. Okay, Ashwin, and you will get the idea on the YouTube channel. You will get the notification also. Okay, what are the batches detail? You can visit the app also. Okay, bacha. Now, first of all, please solve this one, each and every one. Minus 14.25. Tell me, my dear, what is the correct answer? Yes, Ashwin. Same faculty, don't worry about that. Yes, you can write 14.25. How you can write? 8 for 12. Yes, yeah, no. How you can write directly? 1248.5.25. So you have to write 14. 8, 12, this 0.25. You can write in this manner. Very good. You are getting the answers. So without wasting time, I am writing. How you do? Implicit. You have to shift 1, 2, 3 bits. So sign is what? Negative na. So S will be 1. Mantissa will be 11001. Small e will be plus 3. What is the bias here? Bias is 127 for a single precision and 1 27 for a single precision, and for a double precision I will tell you, just keep patience, otherwise hoch poch ho jayega. Now here, what is the capital value of E? 3 is the exponent value and bias is 127. You will get 130, my dear, you will get 130. So how you can write 130? 128 and 2. Sign is 1 bit and Mantissa 23 bits. So you have these things only after remaining all 0. If you want the answer from this, if you want this value from this, you can calculate how? Minus 1 की power s 1 dot m into 2 की power capital E minus bias. I am showing vice versa also. Minus 1 की power 1, s is 1 na. 1 dot Mantissa is what? 1 1 0 0 1 0 0 0 0 0 0 0. 2 की power capital E is what? 130, bias is 127. So minus 1.11001000 2 की power plus 3. Mean to say you have to shift 3 bits. 110.01. So how much you are getting? 1248.5.25. 12 14 14.25 negative, because MSB is 1, my dear. You can see question to answer and answer to question. Crystal clear, everyone? Crystal clear, everyone? Tell me fast, tell me fast, tell me fast. Crystal clear? Now listen, you know these points, because sometime actual में what happen na, in a gate directly straightforward question is asked, but sometime if different varieties of ask na, you will be in trap. What you have to do, please remember this point. What I'm saying, IEEE is having 2 format. First of all, I'm explaining IEEE is having 2 format. First one is single precision and second one is double precision. What bacha? Single precision and double precision. Please remember only one thing, single precision and double precision. Single precision is what? 32 bit. How much? 32 bit. And double precision is what? 64 bit. Double precision and single precision. Here S, E and M. S is 1 bit, E is 8 bit and remaining is Mantissa. Clear bacha? And here S, E and M. S is 1 bit, E is 11 bit and M is 20. Remaining is how much? Remaining is how much? 52 bits. So what is the value of bias here? First you have to focus only these things, remaining concept will be same. Here bias will be used 127 and here the bias will be used 2 raised to power 11 minus 1 minus 1 1023. Clear bacha? This is the bias. Now first of all Anjali, we are live last 1 and approx half an hour and 90 minutes 85 minutes. So bacha, here what is the plus point? Why we are using floating point representation, my dear? Why we are using IEEE 754? It is a standardization. And why we are using? Because in a normal floating point representation you can't represent a 0 as well as infinite also. So in a normal floating point representation they have lots of limitation. So to overcome from these limitations, we go for IEEE 754. And what is the IEEE 754? Remaining concept will be same, only bias will be fixed. Here bias will be fixed 127 and 1023, my dear. S 1 bit, E is fixed 8 bit and remaining is Mantissa out of 32 bit. Out of 32 bit remaining is Mantissa. Now it have some points. Yes Ashwin, here it is. It have some point ki if your S will be either 0 or 1 for a positive or negative. If your E is 0, Mantissa is 0, then you can say either it will be plus 0 or minus 0. Plus 0 or minus 0. If all E1, all E means 8 bits. 8 bits means 255. Mantissa is 0. you can represent plus or minus infinite. Otherwise what happen if E12 like 1 to 54 menticize something, then implicit normalize, otherwise fractional form. Or if E255 menticize not a zero, then it is called not a number. Mean to say, what I am saying, if your E is 0, then there are two cases. If your E is 0, then there are two cases. The case number first, my dear, if M is 0, value becomes 0. If M not 0, then fractional. And if all E1s either in double precision 2047 or in a single precision 255, then 2 points. If M 0, then infinite. But if M not 0, not a number. You can see 255, M not 0, not a number. Crystal clear? I summarize beta for a rememberize. I am written here kya? What is denormalized number? Ki you are not converting into implicit 1.0 form, 1. something. Shivam Jangid, whatever number is given, you are taking that same, not doing any conversion, not doing shifting of mantissa. Clear, Shivam Jangid? This is the meaning of unnormalized. Now listen what I am saying. When your E is 0, Ashwin, you are asking ki sir how to remember these things. When E is 0, then 2 points. M 0 or not 0. If M 0 means 0 and 0. 0 and 0. No beta, that is used for normalize. That is used for normalize only. So if E is 0, then value becomes 0. If M 0, if M not 0, then it is a fractional. If all E1, then it may be infinite or not a number. If M 0, then infinite. If M not 0, not a number, you can see. If M 0, then what happened? देखिए बच्चा, if E is 0, there are two cases, either 0 or fractional form. If M E255, then 2 points, either M0, M not 0. If M0 plus minus infinity, if M not 0, not a number. Crystal clear bachcha? Same thing here. Here only bias will be 1 0. Bias will be how much? 2 raised to power 11 minus 1 minus 1. 1023. Okay. It is also called as, याद हो गया? Very good. It is also called as axis 1023. Listen, sometime you will get axis 32. What is the meaning of axis 32? S, E and M. It is not given ki what is the partition. Please listen one more concept. My dear. Listen one more concept. What I am telling. Please listen. S is 1 bit. It is saying 16 bit. Complete is 16 bit. Now you don't know what is the value of E and what is the value of M. Whenever bias axis is 132 means what? Capital E means E plus bias na. I am telling two tricks. Listen everyone. E plus 32. Axis 32. You know axis code also. Either you can calculate in this form or how you can calculate 2 की power k minus 1. Without IEEE I am telling first. 32. 2 की power k minus 1 equal to 2 की power 5. K minus 1 equal to 5. K equal to 6 bit. K equal to 6 bit. So this will be 9 bit. And if K is 6 bit, then bias will be 2 raised to power k minus 1. 2 raised to power 6 minus 1. What? 32. So whenever sometime they given axis code, axis 16, axis 32, what you have to understand ki bias value is here 32. Why 32? Because that value is equivalent to 2 की power k minus 1. You can see exponent is 6 bit. When exponent is 6 bit without IEEE 754, then what is the bias? 32. Crystal? Or if it is IEEE 7, IEEE 754 is, then you can say 1023, or here bias will be 2 raised to power 8 minus 1 minus 1, 2 raised to power 7 minus 1, 127. You can say x is 127 also. Hope so it is crystal clear, everyone. Now solve this question. Crystal clear, bacha? Now solve this question. What is mentioned? Consider a 64-bit register. It is showing. Please, 64-bit register है IEEE double precision. What is the value of number of 64-bit? S 4 8 11. This is the 11E, and this is what? Mantissa 52. So here all E. Why you fear? Your Vijay sir is here na. Why you fear? Here all E are ones. Means all E are ones means E2047. Then there are 2 points. Either it could be infinity or not a number. When it will be infinity? When M is 0, then infinity. When M is not 0, something, then you can say not a number, my dear. Clear, everyone? So here M is 0. So it represent infinity. And which infinity? Because S is plus na, because S is what? Only 0 na. So if S is 0 means what? Positive. Crystal clear, everyone? Each and everyone crystal clear? Kindly write down in chat box if are you getting or not. Crystal clear? Everyone acknowledge fast. Clear, everyone? Acknowledge fast, my dear. Then in the last I will talk with you also. Please acknowledge fast, first of all. Till now crystal clear? Anjali? Beta, what is the GOAT? What is the GOAT, Ashwin Mahajan? GOAT, what is the meaning of this? Tell me fast. Each and everyone, tell me fast. Greatest of all time. You are the God. Okay, my dear. Now, please, first of all, put your pen down and acknowledge in chat box. Now, I want to give some tips. Because greatest of all time. Thank you, my dear. God bless you, everyone. And I want to discuss something with you. Please put your pen down, everyone. Put your pen down. I want to discuss something with you. Everyone, before that, you acknowledge in the chat box. Write down in chat box. Now, listen, macho. What I am saying. Because don't worry, Muhammad Asif. Now listen. You can watch the recorded also. Don't worry. Now listen what I am saying. Please, each and everyone, put your pen down and listen what I am saying. So this is, don't take seriously so much now. Don't take too much stress. It is just a paper. It's just a paper, not a life. Yes, I'm saying also a single piece of paper can't decide my future. That is the wrong statement. Even I was saying these statements. Yes. And now please now, because today is the 30th January. You have less than a week, because Saturday you have a paper. Today is a Monday. Today is Monday or Tuesday? Monday. Yes. Because I don't remember the days. Daily I have classes and each and everything. We are working for you. only, my dear GW soldiers. Now what I'm doing, what I'm saying, ki please give your best, whatever you done na, whatever you done, whatever you feel comfortable, do only that part and do the revision. Do the revision and give your best, my dear. Doesn't matter what will be the result. Don't think right now about the result, and don't think is this much is not cover, this one I forgot, this one I am not able to cover. Should I consider a new topic? Should I start this topic? Should I do this? Should I do this? Should I do this? No, my dear. Now it's not a time to pick any new subject. Just revise whatever you have done. Believe in yourself. You can give one or two mock, that's all India mock test, one or two complete mock test, and Anjali, you can take, already I have taken, Anjali, and you can watch last video of the crash course. I have taken in that also. Anjali Sahu, clear hai bachcha? Anjali Sahu, in last crash course video number 8, I have taken that part. You can refer that video also, don't worry. Now listen, what I am saying, that is also more important. Anjali, please try to understand what I am saying. Mohammad Asif, you join late. Okay, and DMA, it's a very simple preparation time, data transfer time, one formula, and one for count register, which I have taken in today class, and one from program driven IO, interrupt driven IO, that I also taken, and disk scheduling you'd already done in OS, and disk structure, platter, track, surface, we already taken in crash also. So don't take so much stress about these things. Okay, bacha, and I already covered in crash last video, don't worry. Now listen what I am saying, please. How your preparation is going on, you tell me, each and everyone. And I want to talk with you because today is the last day in which we are communicating. So I want, yes, Anjali, very simple beta. Yes, I have taken one two question today, already taken. Now listen, you are asking, sir, kitna marks chahiye, how much confidence low ho raha because of test series. Don't fear about that. What happened in test series, some of the test series intentionally, listen, intentionally we are inserting some question, you will get confused, yeah, scared. Okay, my syllabus is 80% complete. Okay, you know, 100% syllabus not done by the topper itself also, not done by the topper. Think in practical manner. What aptitude, we have a 15 marks, 15 marks of aptitude. Math 13 marks, but we will combine math and discrete mathematics and graph theory, more than 20 marks. Yes or no? C, DSA and algorithm, 15 to 18 marks we can combine. I'm writing on average, not go strict only this marks value. This range may be vary. Okay, now OS, DBMS, CN, COA, these four subject also weighting, having a weightage of 30 marks if I'm thinking about these things. TOC compiler also 15 to 20 marks. Think it. देखो बच्चों, please think positive, think positive. Listen, this is the 15 marks na. I guaranteed, if you are an engineer, grown and brought up engineer, you have little bit mind. Any student without reading aptitude also, he or she can score at least 8, 9, 10 marks. But I am again saying कि please go through the aptitude part also. Why? If you visit aptitude part also, then you feel confidence कि this section also for me. Otherwise you say कि it is a plus marks, whatever I am getting, this is a bonus for me. Don't, yes, Muhammad Asif, I am suggesting here, listen everyone, don't take for granted कि yes, aptitude is a for granted for me, so I'm not giving the time for aptitude. Aptitude also 15 marks, very simple aptitude also done. So please go through the aptitude part also. Once you go to the aptitude part, what is the benefit of this? Ki once you done this part na, then you feel confidence ki yes, section number 1 non-technical part is also belongs to me. Are you getting my point? Then there is a probability out of 15 you will get 13, 14 or at max 15 also. 13, 14 or 15. Think in positive manner. Let's suppose you are getting 10 marks here. Let's suppose, yeah, 11 marks here. Math, we have a very simple math. Only 3-4 chapters are there. We don't have Laplace and very complex type of probability. We have very simple chapters. You know, discrete mathematics. I don't know so much because Baba sir is a god of discrete mathematics. I don't know, but you know, listen the topic also, na, my dear. Set theory, group function, each and every time you will get predicate logic, one question, group theory, monoid, you will get. Math, 13 marks, yes, it is fixed, but for a computer science, sometime it will count here also. That's why I'm not commenting anything. So in this 20, easily you try to score 15 marks. This CDSA and algorithm, I am telling, in India, again I repeat, the best two faculties, the god of computer science, Dr. Khalil sir, and legendary faculty Pankaj Sharma sir, teach you these topics and taken each and everything from the basic, my dear, from the basic, whatever important, each and everything teach, they taught already. So in this, you try to score very good marks. These are the 20 marks, 30 marks you can try to score in this also. Here, the king of TOC and compiler, again I am saying he is a king, TOC of compiler, Malesham Deva sir also teach each and everything. And some of the direct question asked, Ullman book theorem, Malesham sir only written, make a table, this is a this language, this is a this language. I don't know so much TOC, but Malesham sir already written. That time I was commenting on that video, the Malaysian some writing that things, tables. So very best manner. Digital electronics, each and every student favorite, ever time favorite, evergreen, Chandan Jha sir explain each and everything, I guaranteed you will, once you, if you already attend these videos na, definitely your question will be 100% correct. CN Ankit Dola sir explain each and everything. Even they taken 2 sessions. My dear. OS, again, god of computer science. I am saying god of computer science, Dr. Khalil sir. And DBMS and COA, थोड़ा बहुत मैंने भी लिया है ना. I don't know what you think about this, but you can score very good marks here and here also. In DBMS, one question definitely, one, Muhammad Asif, what is your comment? Yes, I'm suggesting one question definitely. Listen, bachcho, don't take so much of stress ki I leave the job, then what will happen. I'm telling one true story. One student leave the job from out of India, है ना, and he called me, and I'm not telling the name and institute also. He called me and asking about the guidance, and he told, sir, I already left the job and having the package of more than 30 plus 40 plus, sorry, 40 lakh plus in outside the India. So believe me, bachcho, don't think ki if I'm not getting the rank, then my year is waste. Are no, beta. Knowledge. You are completely dynamite. You taken lots of knowledge. Now you are not a like college person which only reading the textbook and pass it. You have a sharp knowledge of each and everything, my dear. Each and everything. Just believe in yourself and give your best. One student saying ki I have done only 80% syllabus. Alright, 100% not required. This is not a university exam ki you have to read 100% syllabus, then you have to fill the sheets, 40 pages, 50 pages, 80 pages, supplementary, complementary, whatever. No, my dear. Here accuracy matter, speed somehow matter, but not so much. Accuracy matter. So believe in yourself, and believe me, you have done lots of hard work, है ना, and hard work always pays off, always pay. I will give beta, I will give, and you can connect with the help of PW app also with me, and we will meet, don't worry. If you get the rank, we will come live again on the solution day, gate examination day. We will come live with solutions on this your channel, and After the result, we will come live with the rankers, testimonials. Okay, so don't worry for that. But again, I am saying, please think positively. Like if you are scoring 11 marks here, 15 marks here, cutoff is here clear. Then this one calculate, this one calculate, this one calculate, digital electronics calculate. 50 already you can do. So don't think in this manner ki what will happen if I'm not getting the good rank, best rank. But do it whatever days is remaining. Only I'm not talking about the last day, before one day of exam, but before 2 days tak, you give your 100%. Give the sitting, revision. If there are formulas, yeah, complexities, just revise. And only give 1 or 2 mock test, maximum 2 or 1 mock test now, because we have a first session exam. So don't take so much of stress. Take a proper sleep before the examination. Take a proper sleep. Don't think in the last night ki ye pad lu, should I read this, oh this one is important. Now this is not the time. Again I'm saying, please don't do this, because you are not assured ki from this tick you will get, or if you're getting, you are able to do the correct or not, because in the last moment will be very tough for you. Okay, already whatever you done, you just wrap up, revise, give 1 or 2 mock test, take a proper sleep in especially last 2 nights before the examination, that last 2 nights, and confident in yourself, and think positively. Don't allow negative thought in your mind. If yes, negative thought is coming, then no, forget each and everything. What is the worst case? What is the worst case? What is the worst case? You will not get the good rank. This is the worst case. Yeah, what is the worst case? You will not selected. What is the worst case? So what happened? What happened? No, please Rishikesh, try to sleep. This is the very important part, because last year and 2015, one student is the victim of this thing. What happened in 2015? Student revising again and doing next topic. Clear? Thank you so much, sir. आपके कारण कोई बात नहीं बेटा, पहले don't worry bacha, don't fear, no worry, है ना. Whatever you done na, that's all. Whatever you can revise in these 3 to 4 days. Give your best in 3 to 4 days, and tell to each and everyone, switch off your mobile. Switch off your mobile in last 3 to 4 days. Yeah, put on silent or vibrate. If there is emergency, then you can call. If very urgency, then you can call. Otherwise, switch off in last 3 to 4 days, and give your best bacha, and believe in yourself. You not done any wrong, so you will get very good things. Doesn't matter, doesn't think right now. Don't bother about the result. Give your best, result will be also best. Whatever will happen, we will check. Don't worry. But don't think ki I leave the job now, I am not scoring in test series very good marks. No, don't think in this manner, because you don't know what is the question asked in gate exam. What is which type of question asked in gate exam? Maybe which question you are doing wrong in the test series, you will solve correct. You will solve correct in gate examination. So don't think so much. Don't take too much stress ki ye nahi hua. Forget about each and everything. Give your best. Whatever you done, just revise. Just revise, my dear. That's all. And believe me, you will rock on, my dear GW soldiers. And one and last thing. This is my, like, you know, one of my symbol. Why you fear Vijay Sari ji here, chol bena dada. Hai. One is also, you not remember, behave like a warriors. Behave like a warriors. You know what happened? I'm telling one story. You know Sunil Gavaskar, when India won the World Cup na in 1983, then West Indies and India, there is one series. Na, then what happened? India duck out. Nothing. Indian cricketer not able to face each and every bowler. Vivian Richards not able to fetch. Not able to face. And India completely destroy. Indian team completely destroy. Then one counselor asked Sunil Gavaskar in the room, and he's saying, if he is the best bowler in the world, you are the best batsman in the world. What happened? Sunil Gavaskar hit 3 fours in that hour, and in autobiography that West Indies cricketer written कि now the Indian cricket has been changed. You know what is the change in Indian cricket? Saurav Ganguly like behave like a warriors. Dhoni behave like a warriors. But keep patience also. Keep patience also and don't do silly mistake and जल्दबाजी बिल्कुल नहीं करने का. Keep patience, check it. Don't think like some student today doing, sir, this question I have seen earlier, this is the right answer. Are giving wrong. Sometimes you will find such type of situation in gate examination. Even I am giving the proof in a deadlock. In a deadlock, there is a one question max of yi yk wala, max of yj yk. I not remember exactly question. Similar type question asked in gate, and one question where p where q wants 1 wants 2 2007 2015. And in DBMS check transaction concept, some question given in this manner, some question given for schema. In COA memory location 2010 value 100 wala, similar type of question asked 50 wala in 2020. So बच्चों don't be, आपकी कोई ट्रेन नहीं छूट रही है, you are not giving the bank PO examination. So बच्चों you have sufficient time. What I am saying, behave like a warriors, behave like a warriors. You are the warriors, you are the GW soldiers. So trust on yourself and please whatever you are doing na, just check. Because what happened when I have taken Super 30, when I have taken PYQ series, most of the students, even today also, most of the students doing the silly mistakes. So don't do these things. Don't do these things, my dear. Please behave like a warriors. Yes or no, my dear? So my dear student, once again, thank you for all of you. Thank you and give your best. Behave like a warriors. Chol bana dada. Yes. नहीं चलेगा, गलती नहीं चलेगा. And don't fear. Trust on yourself, Macha. And we will meet soon. Okay. You are looking from Tamil Nadu Government Technical. Thank you so much. Thank you. And thank you everyone. Thank you and best of luck. Believe in yourself. You will rock on बच्चों. फोड़ दोगे पेपर को, घबराओ मत. Give your best. Okay. So once again, thank you all of you. Thank you and don't take a stress. Prashant and one student who leave the job, don't take a stress. Give your best only. Today time your one priority. Give your best. माना कि अंधेरा घना है पर दिया जलाना कहाँ मना है. Give your best. That's all. Clear? Everyone. So thank you my dear student. Love you all. God bless you. Wish you very best of luck. God bless you my dear. God bless you.